Hello, and welcome to a demonstration video for the Otherworld Stereo Effects Unit. So in this video, I'm going to be telling you a little bit about this product, what it is, what it does, how it was made, and then at the end I am going to give you a tutorial of how you can use it for your audio and music needs. So let's start with what it is. The Otherworld Stereo Effects Unit was inspired by a lack of product in the music market for effects units that are compatible with acoustic instruments. And that was kind of my jumping point for this project. I play acoustic violin and I've always wanted to run it through some effects, but it's very difficult to do, especially in real time. And I wanted something where I could kind of adjust different parameters and get a sound that's really, a far cry from what the original sound of my acoustic instrument is, but wouldn't require me to buy an electric instrument that actually has, some sort of line component. So this is kind of my solution. So what it does is it takes a mono XLR in, and it processes it with digital effects, and it takes your signal and actually makes it into two channels so that left and right parameters can be controlled separately. And then by the time you arrive at the output, you have a fully stereo signal with unique left and right channels that are kind of doing their own thing. So let's take a look at the actual product. So this was printed on 1/8 inch acrylic. This is a box that just snaps together with finger joints, so there was no hardware, no adhesive involved. It can be taken apart and put back together very easily at your convenience. And I actually left off a side for you today so we can actually see what's going on inside here. So if you look in there, that is a custom-made PCB that was mounted to the top panel, which is the user interface. And you can also see in there the brain of this thing, which is the Teensy 4.1 microcontroller, as well as the Teensy audio shield, which is allowing us to do all of our audio processing for this. And you'll also see some other kind of like input output sort of thing. This is actually a line input that I used kind of in like my testing phase that I just kept on in case you ever want to do a line input. And it does involve slightly different code. I won't cover that for the purposes of this video because that wasn't really the intended use of this, but that's worth noting that you could use a line input with a couple of minor changes to the code. And then we also kind of have all of the other input-output things going to this side of the box, which is our input-output section. So what's going on here? So we have an XLR input, so this is just like your standard like 3-pin XLR. We also have a micro USB power unit, and so this could work perfectly well with one of these like micro USB chargers that you can plug into a laptop, which is kind of what I did here. You can see that's just going into one of my USB ports on my laptop, but you can also very easily get a wall charger that's typically used for phones that have this kind of port, and that would work as well. You only really need to be connected directly to a laptop if you're like, uploading code or something of that nature. And then over here we have a line out, so this is an 1/8 of an inch port and it has a stereo signal, so that's kind of cool. So now let's kind of look at the main interface over here. So this is kind of like all right, let's look at the interface. So the purpose of this interface is to kind of visually give you some idea of what parameters are affecting what side of the signal. So let me explain. So we kind of have some just very basic controls up here. So I can just have like a power indicator LED over here, and you would see if I were to plug this in to a power supply, the LED would turn on. And then we also have a gain knob, which is used for your XLR inputs. And this can just turn from anywhere from 0 to about 63 decibels. And I find that usually this product works best when it's at about half, but it, of course, all depends on your microphone. As a note, you'll notice that there's not a phantom power button or anything similar on this device. That is because this device is really, at the moment, only compatible with a dynamic microphone. If you want to use any sort of microphone with powered circuitry, you would need to be providing your 48 volts from another source. This device does not have that capability. But we're going to be using a dynamic mic today, so it's not going to be that important. Let's take a look at this though. So I think something that's really nice about this design is that every effect that is going to be heard on the left channel is on the left side of the device, and every effect that's controlling the right channel is on the right side of the device. So I think it's really nice visually that it kind of shows you what is actually changing and where. So you're going to see that over here we have all of these switches. All of these switches do the exact same thing, and they're just providing bypass for whatever effects you're using. And you can see it's very faintly etched on this. We have 3 different effects. From top to bottom, we have reverb, which is using the reverb on the Teensy Audio library. Then we have delay, which is using the delay tool on the Teensy Audio library. And lastly, we have filter, which is just using the very basic filter function on the Teensy Audio library. So these switches are all just bypasses for the effects. It's just very simple on and off. And then for the knobs, they all kind of control different things depending on what the effect itself is. And they're very faintly etched down here, but it might be a little bit difficult to see because of the lighting and also just because of the color of the acrylic. So for reverb, the first knob we have is room size. So this is kind of just controlling like the reverb time and kind of the, acoustic phenomenon of like being in a bigger room versus a smaller room. And so these both control room size. So it's the left knob for both reverbs are controlling room size. And then the right knobs over here are controlling the mix percentage. So what there is, if you were to look in the actual code, is that there's a mixer unit, which can actually control how much of the dry input signal versus how much of the affected affected reverb signal is moving on to the next phase of audio processing. Next, for the delay, we have 2 delay taps, as they're called in the Teensy program, and these are basically just iterations of the input signal. So this, at the moment, can be changed from anywhere between 0 and 1,000 milliseconds. If you get too high with the millisecond time, it does start to affect the quality a little bit, so I like to keep it relatively low. I did do some tests when I was making this with like going up to like 5,000 milliseconds, 3,000 milliseconds even, and that can be a little bit too much, so I like to keep it relatively low. And so basically how this works is that it's actually hard-coded because of the limitations with how many controls I could put on this thing. That tap 1 is going to be half the loudness of just like the dry input signal, and tap 2 is going to be half the loudness of tap 1. And so that kind of just creates like a nice cascading effect of loudness, so they're not all like equally audible. And lastly, we have a filter. So for the filter, we just simply have a low cut and a high cut. So these are basically just shelf filters. So they're not like kind of like your typical bell curve that you think of with EQ. They're really just like cutting everything off. They're cutting off at 12 decibels per octave. That particular parameter is not adjustable, but the corner frequency is, and that's what these knobs are doing. So you can go anywhere from about 20 hertz to 12K hertz with both of these. Yeah, and you can create, you can do all high pass if you wanted, all low pass, or you can do both and create kind of like a band pass effect. So that's pretty much it for controls. And so now I'm going to show you how I use this. So for this particular demonstration, what I'm going to show you is how I would go from a microphone into this unit and then out into an audio interface for recording in Logic. So let's start that. So I'm going to show you some of the materials I have. So first, I have this SM58 microphone. This is just really standard dynamic mic. Next, I have this Scarlett 2x2 interface. And this is connected to my computer right now. And that's going into Logic Pro, but you can use any DAW you want. And I have my input and output set to be my Focusrite. I do want to be monitoring this today while I'm adding effects. So I also have a nice pair of headphones. I'm going to be putting these in my headphone jack on my Focusrite, and I'm going to be turning up my monitor volume. Next, I'm going to plug in my unit. So I'm just using the micro USB that's coming out of my laptop. And we have our power on light on, which is always a good sign. And then I also have this XLR cable, which is currently plugged into my microphone that I'm going to be using today. And I'm going to plug that into the XLR input. Just right here. So once you have a nice connection established, we now have to set up the output for this. And what I'm going to be using today, just for this particular application of going into a DAW, is this splitter cable. So the really nice thing about this is that the part that's going into your stereo line out, which is a single port on this device, is just one single 1/8 inch jack. But then for your other end, it's actually split into two mono sides. So you can go into a channel 1 and channel 2 in an interface. And then you can have them kind of as separate channels, or you can kind of interleave them once they're in the DAW. If you're going into like a stereo speaker set, obviously you would not need a splitter cable because a lot of them just have a single aux in. But for this particular application, I do want to have two on one side and then just this one for the actual output of the device. So let's go into this line output. I'm now going to plug each of these into All right, folks, we have signal. Woohoo! Okay, so let's do a brief rundown of what's going on over here, just in case anyone forgot. I think it's always good to go over. So right now I have an XLR cable coming out of my dynamic microphone and into the XLR input on my device. I also have micro USB power going into this thing so that it works. And then the line out is going into a stereo splitter cable, which is going into channels 1 and 2 of my audio interface. And there also is a direct monitor going up to my headphones so I can hear this. So yeah, let's start playing with effects and see what happens. So okay, let's begin. So what I have right now is I already tested this a little bit in advance, and I made sure that the splitter cables are set up in such a way that channel 1 is left and channel 2 is right. That's just kind of the way I like to have it set up. So now I'm going to start turning on some effects for you. And you're going to hear that they're only coming to you in one ear at a time if I only have one side turned on. So right now, all the effects are off. And I'm going to start slowly switching things on, and you're going to hear that there are different effects in the left and right, or you're going to hear that maybe one side has an effect and the other has none at all. So let's get started. I'm going to start with reverb. I'm going to put a little bit of reverb in your left ear. It's actually not a little bit, it's quite a lot. Okay, so now we have a very long reverb in the left ear. You're going to notice if you were to just have a right earbud in right now, you're not hearing anything. It's all on the left. So that's kind of nice. Let's hear what we have on the right reverb. I'm going to shut this off. Here's the right reverb. It's a much smaller reverb. It has a much smaller tail. Also, as a note, you can disregard these little lines. They're not necessarily corresponding with the amount. They're kind of just put on randomly. Anyway, so this is the right reverb. It kind of sounds like a very small resonant room, whereas this reverb on the left was like this infinite, very spooky reverb. So let's try something cool, and let's put both of these reverbs on at the same time. So for comparison, here's the dry signal, and so any kind of sound you're hearing is just the natural resonance of the room. This is no reverb, and let's turn both of them on. Now we have two different reverbs on at the same time. We have a very short reverb on the right ear and a very long one on the left ear. And you can hear a very drastic difference between those two. So now let's move on to testing some delay. I'm back to dry signal now. So yeah, let's try the right delay. Ooh, that was pretty crazy. So you can hear it's kind of just repeating after me. It's kind of like parroting me. So if I were to turn these all the way one way, or all the way the other way, we can kind of change the effects that the delay is having. So this is like practically 0 delay, and then I can kind of start to turn it up a little bit. Kind of sounds, it doesn't really have necessarily a really strong phasing effect as really short delays usually do. It's kind of sounds more like a robot voice. And that's just due to maybe the quality of the delay. But it's still certainly a cool effect. You can see as I turn it up, it's getting pretty hard to understand what I'm saying. Let's try a left delay. I'm turning the right delay off. And I quite like this one. So it's not too drastic. And I think one really fun thing to do with this unit is to have not too drastic in one ear and really drastic in the other ear. So let's try that. Okay. This is the delay. Stereo delay. Left ear, right ear. You can hear it's coming to you at different times. Very interesting. Next, let's try the filter. Okay. So I'm going to start by turning all of these the same way, just for comparison purposes. Let's start with the left filter. Here's the left filter. You can see I'm going to just kind of start moving knobs around. And you'll notice kind of marginal differences. It's definitely harder to hear if you have both earphones in, so I'm going to go with one ear off just so it's easier to hear, and that sounds like about everything is cut out. So I'm going to start turning this back up. Turn this around as well. And now let's try some right filtering. I'm gonna switch ears. So this is turning, 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 turn, 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 turn. Alright, let's just turn both up and see what happens. So this is with both filters on. I'm just gonna kind of set them to random values and see what happens. Alright, and now, just for fun, I'm going to turn all 6 of them on, and we're gonna see what it sounds like, so. Alright, we have all 6 effects on to some extent. And that's going into my DAW, and that's how you're hearing that. I'm hearing myself through my direct monitor right now. You're going to be hearing this as an audio that was recorded in Logic, and then overlaid with the video you're watching. Alright. So, I'm going to move some knobs around, and you can keep listening. I'm going to post some more useful examples as well. Yeah, but that's pretty much it. You're getting some pretty crazy sounds out of this. Maybe not the most but it definitely kind of has character, and it's very formulated. And I think it's just so easy to do. And that really kind of opens the door for working with acoustic instruments and just in general the instrument families that tend to get neglected when it comes to digital effects units. Yeah, so that's pretty much a rundown of my project. I'm going to turn a lot of these effects off because it's very difficult to hear. And yeah, now we're back to completely dry signal. And that's pretty much it. Thank you very much for watching this tutorial, this demonstration, and I hope you enjoyed. Thank you.